Hello! In this lecture we're going to learn about the principle of zero products. The primary reason why we have to learn this is because it would be incredibly useful when we are asked to solve equations of higher degree than linear equations, of higher degree than 1. As soon as we hit quadratics, that's the second degree, or cubics, or so forth, we really need this principle of zero products to solve algebraically without any formulas. So this principle says if A times B equals 0, so you have a product equal to 0, then either A equals 0 or B equals 0. And what I just want you to keep in the back of your mind is this rule. Recall this. 0 times anything or anything times 0 is still 0. And also, if we were to say we had 0 times 0, that would still be 0. So when we look at our principle, we have something, let's call A something, times B, right? Anything times B gets a 0. Well, the only thing that B could end up being, if A is anything but 0, would have to be 0. Because we plug it in, 0 times A is still 0. Or if A turns out to be 0, 0 times anything is still 0. If both happen to be 0, then you have your 0 times 0 is 0. That's the magic of this rule. So once you understand that you have a product, and if one piece is 0, when you multiply by 0, it turns everything into 0, then you're golden. How we are going to use this is a little bit more challenging. So we're going to start off with a nice example, and I'm going to give us a product, I'm not going to make us factor, where we're asked to solve. And the first one we have is x minus 3 times 2x plus 5 equals 0. The first condition that we must have is the equal to 0 part. If it doesn't equal 0, we're going to have to mess with this equation to make it be equal to 0. That is the only way we can use the principle of zero products. Must equal 0. So now that that's taken care of, we have a product of something, an ugly something, let's call him A, times another something, let's call him another thing, let's say B, and the result equals 0. So either A is going to equal 0, or B here is going to equal 0, or both if they tend to be the same answer. They're not going to in this case. So in this case, A is x minus 3, and we're going to set it equal to 0, and B is 2x plus 5 equal to 0. So we'll solve for each one. Now these are linear equations, so we can go back to solving using addition principle. What we do to one side, we'll do to the other. And we have x equals 3. And on the other side, we'll get x by itself. We'll subtract 5, addition principle first. We have 2x equals negative 5. We divide both sides by 2. 2 can't go into negative 5 evenly, so we have x equals negative 5 halves. If you're interested, you could write a decimal if you really must. So both of these are our answers. The nicest way to write it is in one line, where we have x equals negative 5 halves, comma, 3. But you can write it the first way, where I started with the red, or you can write it the second way, where I started with the blue. It doesn't matter. And it doesn't matter if you list 3 before negative 5 halves. So if you really are getting screwy with me, you could write 3 comma negative 5 halves. I don't care how you write it, as long as I see 2 answers. That's all I need. Now, other professors might be more picky. Probably the best way to write it is where you write the smallest first, then the larger. But that's just a biased point of view. So that's how we'll solve these equations.